Lesson 3-1s on square roots. Big thing today, you probably should have dealt with square roots before, but a perfect square. All your answers today will be a perfect square. Basically, a perfect square is whose square root is a whole number. And so everything that you get inside that square root will be a whole number. Square root is basically saying that you have two equal factors of a number. So an example is if you found the square root of 144, the square root of 144 would be 12. Square root symbol would look like this, 144. So if you type that into your calculator, 144 is basically saying 12 times 12, so the square root of 144 is 12. A radical sign, if they come up across that vocabulary term, basically that indicates the square root itself. First example here, the first three examples are pretty generic. You're going to be able to look at it. They give you the square root of 81. Know that the square root of 81 indicates that it is a positive root of 81. The square root of 81 is 9. Second example here, notice that we have a negative sign down there. We have the square root of 16 over 81. Notice the square root here in comparison to the difference down here at the bottom. Okay, note that the first one, the negative square root 16 over 81, the numerator and denominator are both inside the square root, versus the bottom one down here, only the square root is of 16 there. So this is going to indicate that we have a negative square root, being that there is a negative sign out in front of the square root. So we're going to find out the square root of the numerator first, and then you'll find out the square root of the denominator. We know it's negative. The square root of 16 is 4, and the square root of 81 is 9. So our answer in this problem is negative 4/9. Now if you look down to the bottom there, we still have a negative answer. However, we just need to figure out the square root of our numerator, which is 4, and denominator stays 81. So again, note the difference between those two problems. Example 3, you'll notice you have plus a negative square root 1.44. The plus and negative indicates that it is a positive negative answer of the root of 1.44. So again, your answer would be plus a negative here, covering the positive and the negative aspect of square root 1.44. And when you solve here, you'd wind up with plus a negative 1.2. Big thing here is we know that 1.2 times 1.2 is 1.44, and we know that negative 1.2 times negative 1.2 is also 1.44. So the plus and negative there dictates that your answer can be positive and it can be negative. Now we're going to go through a situation here where in example 4 you actually have to solve. Now looking back at your first three examples, there's a positive outcome, a negative outcome, and a plus and negative outcome. If we look at this example here, we need to get x by itself. X is not by itself because it has a square. So maybe make a note here in example 4 to get rid of a square, use the square root. So that gets rid of a square. So when you rewrite your problem here, we have x squared equals 225. X is not alone, so you need, in order to get rid of a square, you need to use the square root. An example here, just to show you that this works, we all know that the square root of 9 is 3. Well, the square root of 9 is basically saying 3 times 3, which gives us 3. So with the x there, the square root of x squared equals x, because x squared is really saying x times x, which gives you x. So if you kind of correlate these here, those would kind of line up, and these right here would kind of line up. So in order to get rid of the square, we do square root. What you do to one side, you must do to the other. The square root of x squared is x. The square root of 225 is 15. Now, we need to determine, is it positive, negative, or plus negative? Well, in this case, we don't know if x is talking about dogs, sheep, ponies, whatever. So if you do not know what your variable is talking about, you need to cover the positive, negative answer in this question. So your answer to this problem is x equals plus a negative 15. It has to be plus a negative since we don't know what our variable is talking about. So now you're probably thinking, when would you know what your variable is talking about? Well, example 5 is going to hit that. Music. The artwork on the square picture in a compact disc case is approximately 14,161 millimeters squared in area. Find the length of each side of the square. So we are given our compact disc. This is the square. We know that this inside piece is the area. Now area is found by base times height. You could also use length times width. And finally, since this is a square, we know that all side lengths are the same. We could say side times side. Now, we could not use side times side for a rectangle because we know that these measures are different measures. So with the different side lengths for a rectangle, you're not able to use side times side. It would have to be a base times a height or a length times the width. But in this case, we're not even using a rectangle. So we come back here to our side times side, our area. To figure out area, well, if you're saying it's side times side, another way to write side times side would be s squared. So we have s squared equals our area. In this problem here, we know above that our area is 14,161 millimeters. So I'd say side squared equals, use my substitution, substitute in for my area. Now you need to get s alone. Solving equations just like back in example 4. Square root both sides. When you square root both sides, you're left with s, which is side. Square root of 14,161 is 119. This is not plus a negative because s is talking about a side. So yes, it can be a positive, but it can't be a negative. Okay, you cannot have a negative side length here. So we need 119. It is positive. We know what it is. Therefore, we're going to leave it as positive 119 millimeters. This will conclude our lesson 3.1 square roots.